So today we are going to begin our section on turning and Fusion 360 for our cam system. Um, what you see on the screen is what I'm calling the Fanic robot socket, and just to give you, without actually having the thing in front of you, um, it's going to be a two-piece object, and so I'll try to kind of move it around. I should have went ahead and made it into an assembly. The back side of it will mount on our robot. I'm going to move it around just a little bit, and so this back side will mount to the robot, the end of the arm, and then we'll have a bolt hole circle in there. And this is a project that we started the other day when we were in class. I didn't add the bolt hole circles to it, but I need to, so it's really an unfinished project. But for what we're going to work on today, it's going to take care of the things that we need to, because we just really want to focus on turning. So we want to talk about not only just the turning aspects of this part, but we also want to talk about how we're going to finish out this part. We're not doing a shuttle chuck to chuck in the same machine, so it's got to be a two operation part, and so we have to make some decisions on how we're going to make this part. So I'll walk you through some of the things that we did in class the other day, and then for the rest of us, we're just going to walk through just creating this part, modeling this thing out, and then applying the machine to it. I've noticed that Fusion has done some updates and some changes in some of its turning, posting, and tooling libraries. So we're going to go through some of the problems that we can kind of come up with through there. They're really not problems. They're actually kind of good situations to come across now. The one thing that I've found with a student is that what they find is that what I find in them is that they always want to be given the absolutes on everything, no gray areas, no variations, when you and I both know that life really doesn't work like that. So you have times where you might be watching a video on a cam system, or so watching one of my videos, and you might be working on a newer version update. Don't just shut down and lock up. The idea is that you're working past that. Think about the way that you'll work in the shop for the next 15, 20 years. There's version and version and version and update after update on these things, and we're always changing, always getting better. So lots of times we have times where not everything matches up just quite right, and so we just have to kind of work through some of those problems and some of those situations. So we've got this part. As I showed you, it mounted to the back side, and then the front side of it looks like this. It's got a 1/2 inch hole that runs through it, and the 3/4 inch reamed hole that runs through there, a bored hole that runs through there. It's a little deep, but not super deep. The idea is what we'll do is we'll have essentially two of these, one on each end, so they would face kind of opposite of each other. There would be a 3/4 rod that went through the middle of this, and so the idea is that they can go, it could be 6 inches long, where you might butt two of them up together, or 8 inches long, a little over 8 inches long if you butted two of them together. But if you wanted to make it 22 inches long, then you could put a longer rod in there. It'd have some set screws in the outside of it. Maybe you put a flat on this or not. One of the things that we talked about in class was trying to manufacture a break point into this. Naturally, it occurs kind of in this section. This one we did not manufacture a breakpoint into it, but we could. So what we could do is we could take a threading tool or some type of profiling tool and machine in kind of a V groove or a couple of V grooves in there. And then that way you've got this hole in there. So this area right here is 900 thousandths. This area right here is 500 thousandths. So you really only have about a 200 thousandths wall. So what you want to do is you want to kind of try and preserve some of the robot's life from having any kind of problems if we put this breakpoint in there. So maybe you put one on one side, one not on the other side. So we didn't manufacture it into it. That is something we could add into our program, or that's something you could also do manually later on. One thing that we really had to think about when we were trying to manufacture this was leaving ourselves enough room to get the bolts in. So you've got your bolt hole circle right here. You've got to be able to get your socket head cap screws in through this area. You've got to be able to leave yourself enough room for the Allen wrench to do its work. This diameter honestly could be a little bit smaller now that I'm looking at it. We did this as 2 inches, but it could be much smaller. This area would need to stay somewhere close to the 2-inch diameter area, and we kind of just left it as it is. The outside of it is somewhat irrelevant. It needs to stay similar in size and shape. You need to make it just the same way that I've made it, and so we just made it in class. We didn't have really anything to go off of. We just kind of used everybody's ideas. We put some 100,000 radiuses around all of these edges. So when you look at the drawing itself, and so I'll flip over here, all of these numbers here as they go across from 0, 540, 100, 1 inch, 800, 3 inches, 20,000s. Those are all center points of those radiuses. So you want to take note of that when you're putting this thing together. That stuff should fall into place if you follow the fact that this is a 45 degree, 155 from there. This diameter is 2 inches. You've got this area right here. You got 3 inches 700 from the back side, so you get a 300 flange there. Oh, I'm sorry, you got a little bit longer than that because we were 4.2, not 4 inches. So you've got everything that you need to do that. If we have problems as we go, we might just add to the print. Like I said, this is really an unfinished project. This is just what we started the other day in class. So now you can see what the final result looks like. I've put a little red anodizing on it just because the blue that I had before seems to be a little hard to view, especially if we're in our classroom setup. And so changed up colors, left it there just a little bit, and it seems to be just a little bit easier to view that way. So all right, here we go. We're going to just start with a new drawing, and we'll leave this one in here as a reference as we need to. So we'll start with a new design. I'm going to go ahead and bring this one up. I'm going to output it as a PDF, and then that way I can have it up on my other screen and be able to continue to kind of reference it as we go. I would hate to ever have to go back to single screen or single monitors. I am anxious to get back to the classroom where monitors are slightly larger and we can even work off of some of the other stuff, some of the projection and some of those other things. One thing I do want to note, I'll bring this back up on the drawing itself. The most critical part of this is really that the 3/4 inch bore, the backside flange, and then the 1.59 bore. So it's this, and this back face. They need to be running pretty concentric. The robot, the way we're going to program it is going to be with teach functions, but even still, concentricity matters, and we want to try and stay concentric as we go with that thing. And so just to bring this guy back before we really get going on the other one, I want you to think about how we should set this thing up, how we should manufacture it. I'll show you just kind of a sneak peek of what we did. We machined it from this side, with the front side being the front side of it. And what we decided is that we would machine this, and that we would part it off, and then we would take it and we would put it in the mill. Putting it in a chuck, clamping on this diameter, indicate this face, make sure that everything is square and perpendicular. We would go ahead and mill this counterbore section out. Then we would go ahead and probably face it off, mill the counterboard section out, and then put the holes in it from the back side. So that way we're taking care of all of that. The only thing that we didn't really cover in doing that was these the set screw holes that'll be on the outside of this to hold that 3/4 inch rod in. So that kind of gives you an idea of what it is, just kind of in a nutshell. We can go ahead and run it through graphics just so we can kind of see how we machined it in class the other day. Let me flip around so we got something just a little more accurate, and we can go ahead and just run this with stock and run it through. So if you notice, we did have one small red area came from this, or that's where this comes from, this little highlighted warning symbol. The idea was is that there was not enough clearance as you come up this face, kind of come into this intersection. We have enough clearance in there. Tool design just doesn't quite show exactly what we have, but it's not a stopper, it's just a warning for information. So let's get back to our new drawing that we've got. We're going to go ahead and get started with the new sketch, and let's see, I'm going to go ahead and flip it over and around just so I can get to something that I feel like is going to be more advantageous to the part that I make. Do something like that, and then we'll flip this baby back over. So it'll help me get my Z set up in order. Now, to draw or to create a model of a turned or round part, all we're going to do is create essentially the profile for it, and then in the way that we extrude it, we'll do a revolution around it. So we're going to draw just kind of half of the profile, and then we're going to revolve it around the center line. That'd be our Z-axis. We'll create the whole thing, the whole image from that point. So I'm going to go ahead and get started. I'm going to draw just a random line going across it, just to give myself kind of a baseline to work off of. This will be deleted as we go. But remember, model drawing, we're just kind of trying to get the rough shape of it, not necessarily be perfect in our dimension. And so we come up here, we've got 45, we've got this, we've got some angle, we've got this flat here, we go back up, come across, go down, and that takes care of kind of a blank rough shape anyways. It's not perfect. Get this out of the way. From this point, I can go ahead and put my counter bore in, just to try and get this thing as close to actual shape as I want. Trim out some of these areas that are unrelated. Can go ahead and trim that out as well. So I'm starting to develop something that looks similar to the shape of it. I don't have any kind of center hole in it yet, but I'll go ahead and put it in now as well. I wouldn't have to put it in now, but I will just go ahead. I kind of like to just know what the thing looks like as I run along through there, okay? And do a couple of trims here and here. Now, if you notice, I left my Z line through here just because I like to have that reference on there. I'm going to go ahead and do a save, and I'm going to call this my Fanic Robot Socket Video. I already have it, and just want to make sure I got this one for the one that we're doing. All right, I'll go ahead and hide that out of there just so we can get a little bit more screen. Okay, so at this point I'm ready to kind of start making some dimensions, making some, bringing some things into size. And so you can see that shape that we're starting to develop. This area is going to be 1 inch, and then this area becomes, let's see, I think that diameter becomes 1.59 divided by 2, 795 for that. So hit it there, 0.795. Bring that back into shape. I hate it when those two things start to get flipped over. So this area here, according to our print, is 900. So that gets a little, oh, it's 900 in diameter, isn't it? So we're going to 450 on the radius of that, much smaller. Bring that in. This is a 1/2 inch, so it's 0.25. That can be just a drilled hole. This is going to be, I did it as 750. Probably if I were to redraw it or to tweak it out, I'd make it 751, 752. So let's just call it 375 just to kind of keep it flowing with the rest of it. This area is going to be 1 inch or 2 inch in diameter, 1 inch radius. Takes care of that. This area, let's see, we've got, back to our print, it shows that we've got this flange at 3.7 and we'll go ahead and grab it to the front side is going to be 3.7. So that means we've got some angle problems. That means this guy should be much shorter. So it's 2.7 now. So let's make it something like 1.7. Try and pull it in. I'm not dimensioned that on the print, but I do know where it should be. Should be about an inch, 321 thousandths. The only reason that I know that is because we went through it just the other day as we made this part. So I start to kind of work off of what I do know, and the part is 4.2, and then we know that up to this flange is 3.7. So we need to go ahead and bring in the rest of our overall length. So that means this flange here needs to be 500 thousandths. So we've got a little bit of an issue. We've got now kind of flipped over backwards. We can do a couple of things to bring that in. Let's see, let's do this. Instead of making that 1 inch 3, let's just delete that out. Let's see if we can't pull this in and call it 300 thousandths. And then let's call this 500 thousandths. Okay, so now we're back into that same spot, which I'm going to over constrain, but if I were to take, need to take care of some problem right here. I could probably just delete that whole thing out. Let's see if we can. Nope. So what we got a line that was overlapping. Bring that back in there. Group that baby back together. This then should be 200 thousandths. That'd be an over constraint. So if I were to do that, see how it's in parentheses. It's over constrained, meaning that I've locked myself in really too many ways. I've already got my 3.7. I've got my 500 thousandths. I've got a 300 thousandths. I'm just adding too many dimensions in there. So I can take that out. If I want to kind of make the overall length of this thing, I can. But it's going to give me the same kind of issue. That 4.2 can be there. It's just going to really over constrain my area. It just becomes a reference dimension. I can leave it there for now if I want to. It really shouldn't change any. Backside of this, I did lose my dimension from here, so I'll go ahead and put it back in 795. Should be good from there. I'm going to do a quick save, just so I don't lose what I got. I've got now a couple of things to work off of. I know that my area right here, according to the print, I've got a dimension of 3.7 and then 3 inches 20 thousandths. So that means that this area right here should be about 680 thousandths. Now, one thing I want to caution you on is to be really careful in doing that, because what I've done in the print, let's see, we pull that back out just a little bit. I'm gonna bring that back. I'm gonna pull this away just because it's not really beneficial to me. I need to lock this up to the front of this axis so it's not moving away from it so much anymore. Okay, so this is going to be 45 degrees. So let's work off of it for just a little bit. We're going to lock that baby in. So here we go. Luckily that already hit. 135 is 45, so we're locked in there. Let's see, that dimension from this front area here to here is 540. Let's see, I'm gonna need to pull that back just a little bit more to bring that in. I can do that a couple of different ways. Let's get that back there. Let's do this just so we're not pulling things away. Let's go ahead and grab this at 2.25, pull that there, and then I take this away, and then I think this is 0.54. Okay, and so it's still the angle, but we don't have a dimension right here for this diameter. So we really kind of need to know what that is. It's got to be pretty close to that 900 thousandths diameter. I'm going to just grab it and see where it's at. So if I go here to here, what do I get? 460 thousandths. It's pretty close to our 900 diameter. I think that that could somewhat jive, and so we'll leave it alone as of now. So we've got 540 up here, we've got 460 here. Probably need to do a little bit of tweaking as we go with that, but we'll leave it alone for right now, just because the edge of this from here to the front is going to be 1.8. So from here to the front is going to be 1.8. Remember, that's to the center. It's probably not where it's going to end up finishing at, but we'll see. We'll tweak around just a little bit as we go. I think that's got most of our dimensions pretty well laid out. I think I do need to come back here and do something. Take this guy out. Go from here back to this front, and that dimension needs to be 3 inches 20 thousandths. 3 inches 20. Bring that back just a little bit. Makes my flat just a little bit longer. Quick save. Now what I need to do is go ahead and add in some radiuses in there. I think I put 100 thousandths radius typical throughout this whole part. It actually only shows one radius on the print, but it is 100 thousandths radius typical. So anytime that you see a radius on that print, it's going to need to be 100 thousandths. Okay. And that 100 thousandths is really just a number, just an arbitrary number that we picked just to give ourselves a little bit of radial relief through there. Okay, so we've got those two. We're going to grab this one right here. Grab this one up here. This is probably one of my favorite things about the cam, is that, you know, making this manually, you have to start kind of make some decisions. You have to make a tool to do this, or if you're going to make this even as a hand program, if a handwritten CAM program or handwritten CNC program, you have to do a little bit of work unless you have auto radius or auto chamfering on your machine. So this makes life much, much simpler. So one thing I want to check, I'm going to put this kind of back into view here. So here becomes a center point for my radius. Now that dimension is different from here, so I'm going to take this and delete it out. And I'll put a dimension from the center point to this end. So now I go 3 inches 20 thousandths. And a couple of those dimensions are going to be just like that. This one's going to be the same way. It's to the center point, not to that edge. Okay, so what we have to do is we have to come in here and grab this center. So I'm going to come up, grab the center here, and grab this very front point. I'm going to make it 1.8. And then the only thing I have really left to grab will be this guy here. And it is 540, so we'll delete that thing, hit it here, go over here, here, and we'll go 540. Okay. Stretches out just a couple things, tweaks just a few things on there. Now if I wanted to get real fancy, actually I think when we made this in class the other day, we put probably a 10 thousandths radius on this edge here. You could do a couple of other things there. Let me save, and then we'll talk just a little bit more about this part. Before we revolve it, there's a couple things that you could or could not have done. You could have not done any of this hole work, and you could do that on the manufacturing side. I like to have the hole in there so I know what's happening as I go along, just to make sure that everything kind of jives right, everything looks right. Another thing I did is I did not put any kind of angle right here. I know that when I make this part, whether I'm running a reamer or even if I were running a flat bottom drill in there or a boring bar, I'm going to have some kind of radius on there. I've not drawn any kind of radius in there, but it's not going to affect it either way. If I've got something about 2 1/4 deep I'm going to have some set screws going through here, and then that's going to take care of my problems, or my situation there. So all I'm really trying to do is stick a 3/4 inch rod in the end of this. So at this point, the only thing I really need to do is I'm going to bring a line down. Actually, let me quickly check overall length just to make sure that we haven't stretched out any. Yeah, we're still 4.2. I'm not going to make that dimension because I don't want to over constrain. I'm going to bring this a line down here, and I'm going to trim it off. Yeah, it shrinks in some dimensions, but what I didn't want to have happen to me is I had that longer line going across the back side of it. I didn't want it to cause me problems trying to make my part longer than what it really was. So still 4.2. Everything's super golden. There are advantages to making this 2 times, once in class and then once for the video. I would love to just do one video and just do the in-class work, but that would, that's about 3 hours of class that we go through, so that would be a long video, and I really don't want to do all the chopping of it. So we'll be okay like this. Okay, so at this point, I can finish my sketch. And then I can do a revolve. So I have my profile. Uh-oh. Got some kind of problem here, don't I? I've got to find an axis to revolve that from. At this point, I do not have that. So I'm going to unselect this. I'm going to select this axis right here. Select my part. Now I've got it going right. So it kind of matters sometimes in the way that you would pick that from. I typically like to go left to right, top to bottom. But for this time, it worked just a little bit better running it the other way. Okay, so we're going to hit OK. We've got our part. Everything looks good on it. If we wanted to, we could bring in a radius on this back side. You know, maybe something here and here. Maybe just 15 thousandths, 10-15 thousandths on the back side, just to make life just a little bit cleaner. Now, as I said before, I think that we'll probably mill that in. And in doing that, putting that radius there and in that corner, you're kind of limited to what you have as far as end mill selection. We're really just doing it here just to make things look a little bit nicer. What we don't have in at this point is the couple set screws in there, and then we don't have the bolt pattern in there. And that's okay, because right now all we are concerned about is making sure that we know how to do the machining for the turning center of the lathe. So now we'll go on down to manufacture. We're going to create a setup. And so here's kind of where we ran into some problems as we were going. We did not have a lathe already pre-made, so when we're working on our mill side, we can go in, grab a machine, and we can find something pretty close. We were using a UMC 750. So what we ended up doing was creating one, and so we can go through the process of creating a machine. And the way we want to do that is we want to go to my machines, and we want to go to local. We're going to go in here to this plus, create a new machine. We're going to create a lathe. And we just need to bring in some dimensions for it. So we're going to call this just a Haas CNC turning center or lathe. And the model, our models are TL1. And so we can put under CNC control, we can put the Haas dimensions. Let's flip it down into inches here. Okay. So we've got our description, we've got our dimensions. That's really just going to be for trying to bring some limits into what we've got and some sizing. Capabilities, ours are only going to be turning, so it cannot do any milling. It does have an automatic tool changer. It does not support preload. It only carries 4 tools on the tool changer. You can have more tools than that, but on the tool changer itself, it's only got that four separate positions. You can use turret position 4, offset number 5, offset number 6, and so you can have maximum or multiples on there. Now let's go maximum, minimum tool weight, and tool diameter. That's going to be just a little bit harder to do. I would just leave those alone if it were me. Workpiece, maximum workpiece, I'm going to call it, so I'm going to say we're going to have about a 10 inch. It'd be my maximum in X, and then maybe in Z, probably 30 inches in Z. And so kinematics, we're really not super concerned about that at this time. We do not have a rotary. We'll leave this machining time as is at 100% and 15 seconds for tool change time. It's off, but we'll leave it alone. We only have flood on our coolant options, so we'll take everything else off. Post-processing would be wherever we want to store this, and then what kind of a programming system that we want to use. So we're going to come into Haas turning CPS, and then so I can put it wherever I want. So I can put it on the cloud, which is a great place to put that. The great thing about that is what you, when you don't do that, if you're going to store it somewhere on your computer, and then you are away from your computer and you're using another computer or a laptop from somewhere else, you don't have the ability. And so one of the greatest flexibilities in Fusion is the fact that it is a cloud-based program, so you can open it anywhere you want on multiple computers. You can have multiple people work on that project. And so if you're storing things on specific computers, you're really kind of locking yourself back in, and you want to try and stay away from doing some of those things. And then here, I think we could probably leave this alone. We're not multi-axis, so we're not really concerned about that. So we've got then, we've got now our TL1. So we've got our machine on there. So we can, this will be our machine that we're going to select. If we need to make some adjustments to it, we can, and we'll just select that guy. And so from this point, we know that we're doing a turning operation. We don't quite have orientation set just right, but we're not quite there yet either, so we're okay. So we're going to work off of primary spindle. We do not have the option to, or we don't have multi-spindle on this machine, so it's not going to matter. We need to come in, we need to flip over Z, so it's the other direction. The only other thing that we really have is we do not want Z to be at the front of our stock. We want Z to be at the front of our part. And so we can come in here and take a look at our part. We can take our position from the front of this. Our stock diameter, we're going to call it 2.1. For our overall length, 4.5 would be fine, but at this point we could really say that it's 25 inches long. It really wouldn't matter. It would just show the length of the bar. So we'll go in, let's just say it's 5. Offset, if we want to go an offset of 200 thousandths, we can move that back or forward, and or if we don't want it, we don't need to have it on there. We can round up or down, but again, I know what I want to do, so I'm not typically going to do a lot of rounding in my dimensions. So I'm going to bring this up to 2 1/8 just to keep fractionally correct. Post-processor side, at this point, I can call this maybe 1, 2, 3, 5 for our program. We can put any kind of comment in there. Come in here and we grab one, and that's going to be G54. So for our offsets, everything else seems to jive, looks pretty good. So far so good. We may come back and do a little bit of changing. The only thing I'd really change here, if I went back and did anything, I might change my safe start or a reference to 100 thousandths in front. That's just a personal preference. You definitely don't need to do that. Okay, so from there I think I'm good with my startup, and check here where we are on time. And so we'll do a quick save just because we got our shape here. And so I can rotate this thing around. Okay. And so I've got my part. I've got it essentially sitting in the chuck. I'm kind of cocked at an angle from it. If I want to, I could go ahead and start putting some setup stuff in there. It's already helped me as I've already put some of that information in there. 1235 is my part. We're going to call this the FANUC, caps lock, FANUC robot socket. And we're going to call this from our video selection. Okay. Our program is going to end in an NC file extension. And then we're going to do we are in a turning operation. We are using a Haas machine. We are in the Haas turning land. That way our post will be in that. And then do we want to have any of these other things set up? So do we want our groupings to be set? So do we want to write our machine code? Do we want to have a write on there? So is it going to here it says the output the machine settings in the header of the code. So we don't want to necessarily have that format in there. So I would leave those two things alone. Our sequencing numbers, do we want our sequence numbers to be 1? Or increments of 1? Do we want to start with sequence number 10? How do we want those to go? Do we want to go with 5s, 10s, 100s? Do we even want sequence numbers at all? So I might not even want sequence numbers, so I turn that off. Our home position, G53, do we want it to go home, or do we want to just find ourselves moving out of out into a safe spot? Do we have a chip conveyor? We don't on ours. Do we have a manual tool changer? No, we do not have that on ours. Our max spindle speed is set for 6,000, so that's an override that we're able to put in here. I'm going to max our spindle at 1200 just to be on the safe side. Do we want optional stops? Do we want to separate the words with spaces? Show any kind of notes? Do we want to use can cycles? Yes, I would. And everything else, pretty much up until this point, really can't do anything else because we can't post it. We can't really go through our operations because we don't have any yet. So we'll go ahead and hit OK from this point. I don't think that there's anything else really that is going to be different from where we were at. Radius arcs, maybe. Use simple thread cycles, probably not. Let's see what it's going to look. I don't want to use a G92 if I don't have to. I'd rather use a G76 in my programming just because it comes out cleaner. We'll take a look at both of those as it goes. No tailstock. Built in, I'm not sure what that is. Some of that stuff's grayed out, so I can't really see all of those. There we go. I don't necessarily want to use some of those high feeds and some of that other stuff, so I'm going to leave that stuff out. I'll probably play with some of those things later on, though. So at this point, I'm going to hit OK, and I've got that set up. Do a quick save. I get a red exclamation point because I don't have an NC program attached to it. I don't have anything attached to the output, but there's nothing there, so I can't really do anything yet. I want to put my part in like it would look like in the chuck. So imagine that the chuck is on the left-hand side of our part. All right, as we go, we're going to come in and we're going to follow along on the turning side, and we're going to go essentially left to right. Now, yours might look slightly different than mine. That's okay. If you don't know what all of these descriptions are, you can come down here and grab them from here as well. Typically, it's going to work kind of like this. We got our facing move. We got our roughing move. Sorry, we've got our finishing move. We've got some options where if we wanted to face it all off, we could. And then we also have our parting option. So we're going to do basically a turning face, a turning profile roughing, and then a turning profile that's going to be our finishing. And then we'll do a part off. Okay, so no transfer, nothing like that, nothing fancy, just pretty straightforward, pretty simple. So we've got to come in and we've got to select a tool. Now, what I've got, I've already got some stuff set up. I already have a tool in here, a VMNT. If I don't have a tool, I need to come in and just create a tool. And so I've got a tool list here. that has just different tools in it. And so if I want to make a new tool from there, I can go in and just create a whole new tool. Okay, so I can go into turning, and then I can find, so maybe we just call this a profile tool. Now, one of my favorite things is to not, this is probably my least favorite way, profile turning tool. It's probably one of my least favorite ways to create a tool, because what I like to do is I like to copy off other people's stuff, and so I want to try and use something that somebody else already has. And so I'm just going to call this a V N M T, T, and so it's going to be okay. So let's see if we can figure out what we're using on that. So we'll go with let's see if we've got a 35-degree diamond that we can use. We've got 75, we've got 85, 55 is close. I think we have, there we go, 35. Okay. So I feel like my letters are right, V, N, M, T, and I feel like that's what I had there a second ago. So for thickness, let's see, thickness, I think we are going to use something like a 432, so 1/4 inch thickness. Corner radius on this thing is probably going to be somewhere around the 15 thousandths, so we're going to call it a 1. Yeah, we can do turning general with that. That's inch, it's also carbide, so we can leave it alone. There we go. I need to switch this around. This needs to be a 1/2 inch tall, and this needs to be 187 on the thickness. So we are a VNMT, and we are a 431. So I don't know, maybe I would kick this up to a 2 just to give myself a little bit of corner radius in there. Either way, it's going to work, because our tools that we're cutting, or our profile that we're cutting with, is 100 thousandths in there. So this tool nose radius will be 30 thousandths on there. It's really just about 32 thousandths, 31 and a couple tenths. But it's going to be able to take care of all of those radiuses in there. So VNMT 432 is going to be our tool. Holder is going to be a 1 inch standard tool holder. Setup is pretty normal on there. Let's see, surface footage. Let's change this just a little bit. It's pretty heavy. So let's go to something like 12 for that. The rest of them should follow for our lead in, lead out. We do want a coolant flood going on there. Post processor, we're going to call this probably tool 1, just our turret. And so compensation for that. So turret position 1, offset 1. And then we can just hit accept from that point. That is our tool, and we can select it. Okay, so I'm going to flip around just so we can see it just a little bit better. Okay, and pan up and over just a smidge. So we're going to use this tool quite a bit. I got a max spindle speed there of 5,000, but in our setup we maxed our spindle at 1200 RPM. So this is going to be our operation. This is going to be our safe clearance area. That's probably something that I would change around as I went along, just to make things a little bit better. One of the things that you got to think about is, do I really want, do I want to spend the time to really tweak some of those things in or not? So here's what I mean. If I'm going to make one of these, to take the time to change these numbers around so it's really close here, and bring some of these other dimensions in. Does it really matter at this point? Yeah, maybe not. If I'm running, kind of makes a difference if I'm making 1 or 100 or 1 or 100 thousandths. I can also come in and make some of those dimension changes here. So for me, I'm going to have a really hard time leaving some of those numbers oddball like that. So I might just go to 50 and then maybe just go to 50 again and just consider both of those the same. And then stock OD would be fine for that. We're saying that this is solid stock. It does not have any kind of, it's no tubing, so it doesn't have a hole already built into it. Now, tolerance-wise, for roughing, it's not really going to matter, but I'm going to call it a thou, just because. Compensation type is going to be in the computer, so I'm going to let it. If we're using cutter compensation, the computer's going to take care of our problems or take care of our compensation rather than us going in and doing any kind of tool compensation. How is my lead in and lead out going to work? And then is my retraction going to come all the way back, or is it just going to go to a safe or a minimal area? I'm going to say full retraction. So everything seems to jive, seems to look pretty good. Hit OK. At this point, all I've done was face this part off. Okay, so even though I've only really done a small area of work to it, I have also set myself up for quite a bit because I've created the tool that I'm going to use throughout the entire time. Okay, so this profiling tool that we created, that we took the time to create, takes care of some of that stuff. So I'm going to close this. If I want to satisfy this and get this out of there, I can go into operations. I got my face now set up, and I can hit OK, and then that goes away. So if I got a problem with exclamation points or warning signs, I can get rid of that now. Not have to worry about it. I really don't care too much about that, so I would probably just leave it alone if it was me just running through on a normal day. So I've got my part. I'm going to skew it just a little bit so I can see it. Now I'm going to go into my roughing. So the other day, some of the people in class did not have this adaptive roughing. That's something I like to play with just a little bit. I know we've become pretty big fans of adaptive milling. It really takes some of the thought, some of the decisions out of the roughing for the outside of a part, kind of taking it out of our control and something we don't have to think about. So you may have that. If you have that, you're welcome to play with that. If you don't, we're just going to go to turning profile roughing. We've got our same tool already set up in there. The rest of the things are really starting to kind of glide along, so things get much easier. We've got it set up for 12,000s. We've got really kind of everything set pretty much the way that we want to. I'm going to take this offset and bring it down to 0. And again, do we want to go horizontal passes? Do we want to go vertical passes? Are we reverse cutting? No, we're not. We're going to just do horizontal passes. We're just going across it. Allow radial grooving. That's going to allow it to kind of come in here and do some chopping away at some of these other sections. Do we want to use a can cycle? If we can, we'll see what it looks like. We're going to leave stock on this. I want to leave 10,000s on the diameter and maybe 5,000s in Z. Again, compensation will be in the control rather than I'm using in computer rather than in control for my roughing. And then all my safe retract will be just fine. Get that out of the way. Take a look at what my roughing looks like. Bring it around to the front. I get the same warning that I got before. That's really just because I got a possibility of having a little bit of an issue right here. I know that I don't, but I will go ahead and just run it and we'll see what it looks like. Kick it up in speed just a little bit. Okay, so everything seems to jive right. Everything looks good up till now. Close that. Don't want to spend too much time in graphics. We do have that habit of kind of watching this thing over and over again. So at this point, I could go in and just duplicate this and then change it from what it was, or from roughing to finishing, but we won't. We'll go ahead and just go in, create turning for finishing. We're going to use the same tool, no tailstock, keep everything kind of the same as we go along. One thing that I want to change is my feed rate. Maybe go to about 8 on that for my feed rate. I'll go ahead and bring this down to 0 as well. and then come in and hit OK. And that should take care of our finish pass. We'll do a quick graphic over that. And who does not want a tan or beige part? So we've got that. It looks good at this point. And so I do want to do a save. We get some of these instructions here just because of our clearance in these parts. We can change that if we were to tweak our tool just a little bit degree-wise, or just do some small changes to our part. We could get rid of that, but it's just a warning. It's actually not even going to affect our part at all. Now from this side, I think I want to go ahead. Well, I know I need to go ahead and put my 3/4 inch hole. I think I'll probably go ahead and put my 1/2 inch hole from the back side in whenever I do my milling. Just because I don't think that I have a drill long enough to get through there, and I really don't have probably tool pockets to do what I want. So I'll go ahead and bring in my drilling. I'm going to go in, I'm going to select a tool. If I don't have one, I'm going to go ahead and make one. Now what I want to do is I want to come in here and I can go to hole making. See if I already have a tool set up for that. If I want to search through there. So maybe I've got just a straight drill. This is going to allow me to start kind of squeezing down on some selection. So if I want, say I wanted a certain flute length or a certain number of flutes, I can start to kind of work down on what that is. I don't know that I have a drill that size. I know what I used the other day in class, but here is a 3/4 inch drill, and it is it's plenty long to do it. And so if you don't have one of these, go ahead and create one of these. It's going to be no different than just our tool that we created before to do our turning with. We're going to go ahead and put it wherever we want to store our tools. I store mine in the SFCC tools on the cloud. Hit my plus and then create my drill from there. I'm going to use the one that I've got. I am using aluminum drilling. That is what I'm doing, so that works out pretty good. It's a little faster feed rate than I probably would choose. So let's look. I want to make sure I change how I'm drilling. I'm going to do a deep hole drilling, so I want to do a long. I want it to come out every time. So my peck depth that I'm going to do is 100. I'm going to do 125. Just don't know how to type. So 125, and that'd be fine. We'll leave that alone. It's no big deal. Pick our whole faces. I always find that strange that the whole face is the diameter. The whole face to me seems like it should be this front face. Let's see what that looks like. And so that's tool 2. So we're tool 1, 1, 1, and then our drills are 2. And let's just go ahead and run it as a quick graphic. Kick this thing up here. And there's our drilled hole. Only things happen that fast. It would be wonderful. Okay. Let's see. I think that we are probably ready to, what was machining time for that? 26 seconds? Maybe. It's only going about 2 inches deep, but it's maybe a little faster, or maybe a little too fast. The only thing left we have to do on this part is going to be part off. I will part this part off just a little bit long, and the reason for that is because when I do my second side, I want to chuck it up in the mill and in some type of either soft jaw operation or 3-jaw chuck. If I'm doing this in a 3-axis machine, I'm probably just going to take and bore some jaws or mount a vise to the table, drop the part in there, set a stop on the bottom of it, indicate that part around. I'm going to mill off the back face of it. I've got my 3/4 hole in there, so I do have to make sure I had this thing indicated pretty good when I go in. And then, so I want to probably do my indicating on this face just to make sure it's in there nice and square. And then I want to face off this back face. I want to counterbore this section right here. This, get that flipped around so we can actually see it. Right there. Counterbore this face, and then go ahead and put my 4 holes in. And then, like I said earlier, side operation to take care of this. If I was doing it on the 5-axis, I could probably go ahead and just knock out everything at once. I cannot do that from 4-axis. 4-axis, I could get the holes, but I couldn't get anything else. So, kind of limited in a couple of options. I guess if I had a fixture, I could go ahead and do this and then this, kind of all from one shot. That might be something fun to make. A fixture that would hold it up in that chuck, and then rotate it around 90 degrees and then hit these holes on this side. Might be something to think about. But again, I mean, we're probably making 6 of these, not 600 of these, so maybe not a lifetime concern for us. So we'll go ahead and do our part off. Our part off operation, we can skip all the way down to this turning category, go over to our part off. We got to come up with a new tool, select a tool, find a tool, do something with the tool. I've got an OD grooving parting tool that I made the other day. It's a 125 wide insert. It's got a 30 thousandths radius on the corner. I'm going to part it just a little bit long on there. It's pretty standard grooving tool, so I'll use it. It is currently tool 2, but I'm going to need to change that out because that won't quite work here. So I'm going to leave it for right now, and feed per revolution is good at 3 thousandths. I'll probably leave everything else, probably work just right. Let's see. Let's look at how we offset. Okay, so if I were to go 100 thousandths offset, I start to pull that in. If I were to go negative 100 thousandths offset, I pull that way out. And so if I want to leave some on the back side, I'm probably going to do something like 10 thousandths. 10 thousandths would be plenty long. That way if I zoom up here, I can see no longer does my kind of olive drab line match to the back side, but I've actually got a gap. I do not want to do an edge break. Edge break is nice, but it's not going to work for me here. It will come in and do a quick chamfer on this back edge. It's a really nice feature, and we've programmed it in Fusion, or not. I'm sorry, not in Fusion. We've programmed it by hand before and just using G-code. So here I can come in and do some pecking on this if I want to. So it'd be a G75 in our Haas. If we were creating just a standard grooving cycle, it's going to be a little bit different here. Our peck depth, 400 thousandths won't quite work, so we're going to maybe do something like that. And then it's going to retract 10 thousandths. Reduce the feeds and speeds as it starts to get down. Reduce the speeds and feeds at what diameter? It's got to do it at, and I think that this says it at diameter. We're gonna need to check that out just a little bit. So we're gonna say 400 thousandths is probably not gonna work right. So let's say 300 thousandths. That's gonna be, I think it's on the radius of that. We'll need to see that just to make for sure on there. We do not want to leave any stock. We do want to do a full retract on that, and so there we go. So remember, it does not have this counterbore in there yet. And then this drill looks like it could probably go in just a little bit deeper. Let's go ahead and play with this just a little bit, see how this thing runs. We might do a few tweaks to it as we go. We have a full part off on there. So we'll call that good there. It doesn't graphically show everything the way that I would like it to, but also we do not live in a perfect world. The things that I do want to change is go in here and work with this drill just a little bit. And I'm thinking that we've got, there you go, drilled to the bottom. Let's see if we can get a little bit more drill depth that way. That should give us a little more length on our drill. The other thing that we need to change is our tool number on this. I don't want to do it there, but I want to come in here and just do a right click, edit tool, and post processor, and this is going to be, we'll go ahead and move it up to 4, position 4. So we'll go 1, 1, 1, 1, 2, and then 4. I need to go ahead and do a save because I just realized I have not saved for a while. So now you can see our drill tip actually goes into that square shoulder just a little bit. I'm okay with that. Again, all I need to do is get this a 3/4 rod to stick in there. My print doesn't call for a square shoulder in there, even though it does have it drawn. And I will do probably something along a line of maybe drill a little bit smaller and then come back in with a reamer on it. I want to play around with a couple of different options before I really commit to this. So as far as assignment wise, I really just want you to just imitate just what we've done here, is create this profile, this shape, this part, and you're going to do a face off, and then you're going to do using the same tool, tool 1, turn it, and then face it, rough it, finish it, and then we're going to do just a 3/4 drilling into it and then part off. That should take care of this part of it, and then like I said, we go to the middle for the rest of it. I'll include a couple of other ones that you guys can do start to finish by yourselves. If you guys would, please include, as you submit your projects, if you would submit me your Fusion file, if you would send me your NC code, and then if you would also send me your setup sheet for your tools. That is super beneficial to me, and I will create those all for a submission box for you to put those in. Plan on this one, and then maybe 1, 2, or 25 more for this same module. I'm not 25. But that'll give you kind of an idea of how we do our turning in a CAM system. You're not going to have a chance to stand in front of the machine here anytime soon and do that. But fall is still promised to be an on-ground class. So if you are not signed up, please get yourself signed up and get ready to go. Believe it or not, we are not far away at all from being back to school. So anyways, get this done. We've got a couple more modules to finish up, and then we will be done with our turning section, and then we'll be done with this guy. So hey, have a great day.